On the A320 there are two ventilation systems, lavatory and galley system and avionics system. The lavatory and galley system is fully automatic. Cabin air is passed through the lavatory and galley areas and is removed by an extraction fan. This fan pulls air into an extraction duct and then releases it overboard through the outflow valve. Note, the extraction fan runs continuously provided electrical power is available. There are no controls or indications associated with the lavatory and galley ventilation system. Now let's look at the avionics ventilation system. The avionics ventilation system provides cooling air for the avionics equipment. This equipment includes the avionics compartment, the flight deck instruments and the circuit breaker panels. Let's now look at how the system works. Air is circulated by two fans, a blower and an extractor. These fans operate continuously as long as the aircraft electrical system is supplied. On the ground, provided that the skin temperature is above a specified value, air is taken from outside the aircraft via a skin air inlet valve. The air is blown through the avionics equipment, extracted and then discharged overboard via an extract valve. This is the open circuit configuration. In case of very high outside air temperature, an optional avionics ground cooling unit can be installed. It ensures the cooling of the avionics ventilation air on the ground. The ground cool inlet valve opens when the aircraft is on ground, the engines are stopped, and the ground cool push-button switch is in auto position. The outside air is drawn by the ground cool fan through the inlet valve. The air from the cooling unit is then discharged overboard via the outlet valve. When skin temperature below a specified threshold and in flight or on the ground with thrust levers at takeoff power, both inlet and extract valves close. Air from within the aircraft is used. A skin heat exchanger is used to cool the circulated air. This is the closed circuit configuration. The skin air inlet valve is located on the left side of the aircraft and the extract valve on the right side. Both valves are inspected during the pre-flight walk-around for damage or obstruction. In warm ambient conditions, the system may go to an intermediate configuration. It happens when skin temperature is above a specified threshold and in flight or on the ground with thrust levers at takeoff power. In this situation, a small internal flap on the extract valve opens to exhaust some of the heated air overboard. A section of the ECAM cabin pressure page displays avionics ventilation system information. The vent, inlet and extract indications provide information on the state of the inlet and extract systems. Normally, they remain white. The position of the inlet and extract valves can be seen. In the example shown, both valves are open. The avionics ventilation system is in open circuit configuration. In most cases, you will see this indication when the aircraft is on the ground. The ground cool indication gives the state of the avionics ground cooling system. Normally it remains white. Here, with outside extreme hot air and engine stopped, both inlet and outlet valves are open. In this example, both valves are closed, and the avionics ventilation system is in closed circuit configuration. This is the normal in-flight configuration. When the small internal flap on the extract valve is open, the extract valve indication is in an intermediate position. This is the intermediate configuration. On the overhead panel, there is a ventilation panel that contains 3 push-button switches associated with the ventilation system. During the pre-flight cockpit scan, you should confirm that these switches are in their lights out position. The avionics ventilation system will then operate automatically and requires no further pilot input. In this module, we will look at some other abnormal indications associated with the ventilation system. The fault lights on either the blower or the extract push-button switches illuminate in case of low pressure, computer problems, or as a smoke warning. In addition, the blower fault light illuminates to indicate a duct overheat. These abnormal cases will also be reflected on the ECAM cabin pressure page, depending on the circumstances. In the example shown, both inlet and extract indications have changed to amber. Since this is a fault with the ventilation system, the vent indication also turns amber. The override mode is used during ECAM abnormal procedures. When only the blower push-button switch is set to override, the blower fan stops and the extract fan continues to run. The system goes into closed configuration with, in addition, cooling air from the air conditioning system. Only when the extract push-button switch is set to override will the reconfiguration of the ventilation system occur. To ensure adequate avionics equipment cooling, closed configuration, both fans continue to run. The avionics smoke procedure requires both push-button switches to be set to override. In that case, the air conditioning system supplies cooling air, which is then exhausted overboard. The blower fan stops. Let's see the corresponding indications on the ECAM cabin pressure page. The extract valve is indicated as being partly open. In fact, the small internal flap has opened, allowing air from the ventilation system to be discharged overboard. Let's now study an extract valve fault. You are the pilot non-flying. You are currently flying at your cruise flight level. Everything is normal. Let's look at the indications. A failure message and associated ECAM procedure have appeared on the engine warning display. The ECAM cabin pressure page has been automatically called to show amber indications, and a fault light has illuminated on the ventilation panel. On the engine warning display, read the title of the failure. Before doing the ECAM actions, let's look at the cabin pressure page indications. In this example, vent and extract indications are shown in amber, telling you that there is a problem with the extract system. The pilot flying will ask you to perform the ECAM actions. You, as pilot non-flying, read and perform the ECAM actions. The ECAM actions have now to be performed. In the case of a ventilation extract fault, the procedure is to select Override, the extract push-button switch, located on the ventilation panel. Set the extract push-button switch to Override. When you switch to Override, the override white light illuminates, the fault light extinguishes, and, on the engine warning display, the blue action line disappears. Notice there are no changes in the system display. By setting the extract push-button switch to Override, the ventilation system remains in closed configuration. Both fans continue to run to ensure adequate ventilation. The next step in this example, after checking with the other pilot, is to clear ECAM. Clear cabin pressure. The status page is now displayed, and the engine warning display returns to a normal display. The inoperative system is ventilation extraction. After confirmation from the pilot flying, clear status. The status page is replaced by the cruise page. The status indication at the bottom of the engine warning display reminds you that there is information in the status page. This completes the ECAM procedure for a vent extract fault.